Hi, my name is Rick Zander from Graaf, and I'm here with Alex Canaris. Today we're going to demonstrate the two fundamental differences when powering a belt conveyor. One is going to be a conventional drive system, and the second will be the Graaf drum motor. In this particular case, when we compare the external motor and gearbox to that of the drum motor, we're going to measure the efficiencies and the electrical savings as a result of the comparison. In this particular case, the external motor is mated to a gearbox, which is then run through a 90-degree shaft, which is then powered to the conveyor.
The advantage of the Graaf design is the way the electric motor is coupled to the gearbox. As you can see, they're in line, so the rotor, which is a motor component, is in line with the gearbox. Now, the gearbox, it has losses, but since it's in line, the only losses that we have is at 2% per stage. Since this particular gearbox is only a two-stage gear reduction unit, we have losses of 4%, and that makes our drive 96% mechanical efficient. On the left-hand side, we see the electrical connection box that all electrical connections are made.
Our next demonstration will be a comparison between the external conventional motor and that of the Graaf drum motor, where we put it into a real-life application on a conveyor belt and under load, and we can see the results as to exactly what happened. To make it a fair comparison, we're going to load equally both drives to see exactly how much watts they consume and exactly how much load they experience. As a result, we can then measure the amount of dollars saved by operating a drum motor versus that of a conventional arrangement. Well, in this case, we've got them roughly loaded to the same position at 75 foot-pounds. We see that the drum motor is consuming 577 watts of power versus 721 watts versus the conventional drive. This now it translates into load. The conventional motor is seeing a 23% amount of load. The drum motor is only 12. This is for the exact same comparable amount of torque the motor is producing. So in this particular example, we can see that the drum motor is costing us over an annual period $612. The conventional motor and gearbox, $755. That translates into an actual money dollar savings of roughly $140 to $145 a year by operating a drum motor compared to the exact same load to that of a conventional drive.
Rick, at this point, what I'm going to do, I'm going to increase the torque at 125 foot-pounds of torque. So I'm going to start with the drum motor. So we can see the drum motor right now is producing 125 foot-pounds of torque, and it's 48% loaded. Yep. So I'm going to do the same on the motor gearbox, and you tell me what you see.
Okay. Excellent. So now we take a measured result. So what we can see with these tested results now is that the drum motor is producing 120 to 130 foot-pounds, equally to that of the motor and gearbox. When we compare that, the drum motor is only consuming roughly 658 to 660 watts, whereas the conventional motor is consuming roughly over 800 watts of power. We translate that into the amount of load, and we can see the drum motor is only being loaded at 43%, where the conventional motor is now overloaded or beyond 100%. That represents a significant savings. In terms of dollar amounts, the dollar savings is increased from roughly $152 to $162 per year.
Another important issue that we need to consider is the lifespan of its drive. The drum motor, by producing the same amount of torque of the conventional drive, it's loaded by 40% or 41%, where the conventional drive is loaded by 100%. So taking those two readings under consideration, we know that the Graaf motorized pulley is going to last a lot longer than the conventional drive. So Rick, what can we conclude from today's experiment?
Well, I think from a number of things we can measure, after doing our experiment, we see the obvious energy savings that's associated with driving a conventional versus a comparison to that of a drum motor. Inherently, there's a safety benefit, less moving components, less external. And like you mentioned, less load on the actual drive of a drum motor represents an actual longevity in the drive, which then represents a maintenance savings. And finally, I would have to say something we didn't consider, but something that's very important, and that's space savings. An external motor versus an enclosed motor we'll save a lot of space, and that equals real estate, and that equals money.